Much ado has been made as of late over the object 1I 2017 U1, or Oumuamua, or in some circles, Rama. The story began on October 19, 2017 at the Haleakala Observatory in Hawaii, home of the Pan-STARRS facility, a group of telescopes and equipment designed to survey the sky for moving objects, such as near-Earth asteroids, some of which could potentially pose a threat to Earth. A researcher there, Robert Warwick, picked an object up about 40 days after it made its closest approach to the Sun. This object has turned out to be very strange indeed, and continues to fire debate to this day. From the moment of its discovery, the mystery of Oumuamua has only deepened. When the object was first spotted, it was very close to Earth, only about 85 times the distance of our Moon, or about 0.22 astronomical units, and it had already passed its closest point to us, which was only about 0.15 AU. The Sun, for comparison, is about 1 full AU from us, roughly 93 million miles. Needless to say, this was a very close flyby of our planet by an object in terms of the size of the overall solar system. But it's worth noting here that objects do pass much closer. For example, in 2004, a very small asteroid passed Earth at only about 1/10 of the distance to the Moon. There have been even closer calls, with another such object grazing the Earth's atmosphere in 1972, where witnesses in western North America saw a huge fireball and heard double sonic booms, only to then watch the fireball leave the atmosphere and head back out into space. It simply came in at too shallow of an angle to hit us, but did enter the atmosphere. But as the Great Chelyabinsk Fireball of 2013 showed, or Arizona's Barringer Crater, objects from space do also smack squarely into us fairly regularly. Oumuamua, however, was never in any danger of doing that, and never will be. While it passed close, it didn't pass dangerously so. Originally classed as a comet, and then an asteroid when no coma or off-gassing characteristic of comets was observed, it then quickly became evident that the object was neither a normal run-of-the-mill comet nor an asteroid originating from our solar system based on its trajectory. Instead, it came in at a very odd angle and speed, which was hyperbolic, meaning that it almost certainly had to be of interstellar origin. It was likely that this object had originated in another star system entirely. This led the International Astronomical Union to come up with an entirely new classification to fit this object. The I in 1I 2017 U1 stands for interstellar. It was then given the name Oumuamua, translating in Hawaiian to roughly first distant messenger, though the name Rama was, as I mentioned, also floating around after Arthur C. Clarke's novel Rendezvous with Rama and subsequent installments of that series. It's anyone's guess which name is more fitting, since in the months after its discovery, murmurs of a possible, though highly unlikely, alien origin for this object have surfaced within some parts of the scientific community. But before we move on, let's first talk about the interstellar nature of this object. Is it really from another star system? The answer is yes. Up until recently, there was still a chance it was not. It was possible that something in the outer solar system might have tossed Oumuamua into a hyperbolic orbit, and that its origins could have been our own Oort cloud. This now seems discounted, and the physics of Oumuamua seem to exclude it from being from here. So if interstellar, the natural question here to ask is, what are the origins of Oumuamua? This is unfortunately very murky. While Oumuamua came from the direction of the star Vega, one of the brightest in the night sky that does happen to have a debris disk, it doesn't appear to be related to it and couldn't have originated there. Rather, Oumuamua may have originated from very, very far away, a very long time ago, with some estimates that before encountering the solar system, the object may have circled the Milky Way multiple times over immense amounts of time. Given that the origins of Oumuamua are probably a matter of ancient history, retracing its steps backwards to its origins seems an impossible task, in the same grain as reconstructing the exact movements of a game of billiards that was played 100 years ago by only knowing the trajectory of the last shot. Not enough information is preserved to reconstruct the whole game. Same story with Oumuamua. But there are some other possibilities. In a paper by Corin Baylor-Jones and colleagues, linked to all papers mentioned in this video in the description below, several marginally possible origin candidates are advanced, though the paper itself warns that none of them are particularly good, and in coming years many more candidates may come to light, though those may not be particularly good either. The study looks at reconstructed close encounters Oumuamua recently had, at least geologically recent. One of these was with a red dwarf about 1 million years ago, and another with a type G dwarf about 3.8 million years ago. It's possible that within these systems, Oumuamua might have been ejected by a gas giant, though none of these systems are currently suspected of having planets, so it's more likely it simply passed through them, though not nearly as close as it passed our Sun. Perhaps a better option, given the velocities of Oumuamua, is a binary star system, though no good candidate for a binary system in Oumuamua's reconstructed recent path has yet been found, but the dynamics of such a system might account for Oumuamua's behavior. More likely is that Oumuamua has been wandering the galaxy for immense amounts of time. In such case, its origins will probably never be known. In a paper by Zhang, the idea of further trying to backtrack Oumuamua's path is covered. The problem of tracing the origins of any interstellar object is discussed, and while data releases from the Gaia spacecraft and other sources will make the task a little easier, it will still be difficult, if not impossible, to trace any object's path backwards more than a few tens of millions of years. That's about the best we'll be able to do for Oumuamua and future interstellar object discoveries. However, for objects more recently ejected from their star systems, we may have occasional success. For example, it's known that the relatively nearby young star Beta Pictoris has a huge debris disk that's ejecting material that seems to be passing through our own solar system constantly. That system is also known to have comets, so if one happens to get ejected and sent our way, we should in principle be able to pin down Beta Pictoris as the origin should that happen. One final possibility, at least out of those scientists have thought of so far, is particularly interesting, that Oumuamua may have been ejected not from a run-of-the-mill star system, but from a more exotic source. In a paper by Roman Rafikov, the idea that a white dwarf could produce tidal disruptions of rocky planets ejecting material like Oumuamua, or even ejection during a supernova event. This is due in part because of the odd apparent physical traits of Oumuamua, more on that in a minute, but ultimately this is probably a less likely scenario than an ejection from a binary star system long ago. Regardless of the origins of Oumuamua, as the story unfolded, it became apparent that this object wasn't just interesting due to its potential interstellar nature, but also its shape. As it turns out, Oumuamua is like nothing else we've ever seen as far as objects in our own solar system are concerned. The first hint that something wasn't quite normal with this object came in the form of a very unique light curve that showed that Oumuamua brightened and dimmed relatively rapidly as it moved through the solar system. Initially, this was thought to be due to Oumuamua being a very elongated object that was tumbling, essentially a cigar shape that reflected more light at times as it rotated about once every 8 hours. Another possibility is that it is a very flattened object, something like a pancake. In a paper by Meech and colleagues, they detail many of the strange aspects of this object. Also, for those interested, I recently interviewed Dr. Meech on my second channel, Event Horizon. Link to that show in the description below and in the end screen. Then there is the nature of the object. Initially, Oumuamua was suspected of being a comet. The problem is, a comet passing as close to the Sun as Oumuamua did should have outgassed as volatile ices evaporated, blowing dust off the surface and forming a coma and tail, as in a normal solar system comet. The researchers note that no such cometary activity was seen with Oumuamua, and if it were a comet, there's no reason that the volatile ices it contained wouldn't last billions of years as it crossed space. Yet the composition of Oumuamua, based on spectroscopic study, showed that the surface of the object appears very similar to objects in our own solar system, some of which, incidentally, happen to be rich in organics. But there's a further mystery here. If interstellar comets are common, it seems likely that in the last few hundred years that we've been able to work out cometary orbits, we've yet to see one, and we should have. Such objects should be relatively primitive, ejected from extrasolar Oort clouds. That would mean that their ices should be fully intact, and encounters with stars rare. So if one did enter the solar system and approach the Sun, it should have produced a detectable, possibly even spectacular, comet tail, as objects from our own Oort cloud do, yet be on a hyperbolic trajectory indicating an interstellar origin. That has never been seen. But the idea of extrasolar comets passing through the solar system is an interesting idea in itself, because of the organics they may contain. Comets are a candidate for having delivered the building blocks of life on Earth. There are even meteorites that are thought to be cometary in origin that contain amino acids. While there's no reason to suspect that this happened with Earth, it's possible that interstellar objects may play a role in the universe in seeding exoplanets with the building blocks for life to get started. And it may also be possible, given the right circumstances, for these objects to seed life itself through panspermia. On the other hand, regarding extrasolar comets, there are currently 2 candidates in our solar system that may have once been interstellar comets, but it's unclear how old they are or when they were captured. So perhaps comets passing through the solar system are uncommon, but not particularly rare. Or perhaps it's just a fluke that we haven't seen one, and in coming years, one might yet pass through. But if Oumuamua isn't a comet, then the natural alternative would seem to be an asteroid, though the line between an exhausted comet and an asteroid is rather thin. But it doesn't seem likely that Oumuamua would be an exhausted comet. Rather, it's more likely that this is the closest it's ever approached to a star, and outgassing should have been clearly evident. It wasn't. An asteroidal nature for Oumuamua would be a bit more surprising, however, since asteroids are thought to be significantly more rare in the universe than comets, based on what we know about the formation of star systems. Add in the odd shape of Oumuamua, no other like object has been seen in the solar system to date, and we have an object that stops fitting neatly into either category. That puts Oumuamua potentially into odder, more unconventional territory. One possibility is that Oumuamua might be a fragment of a tidally disrupted planet, in other words, a shard of material from a destroyed world. That would make Oumuamua a much rarer object in the universe than a comet or asteroid, enough that it should probably be intercepted and studied, since we aren't likely to run across things like that every day. In fact, it could be thousands of years before such a thing is seen again. But there's one last possibility on the table, unlikely though it is. This is where the story of Oumuamua takes an even more bizarre turn. As noted by Dr. Meech in her TED Talk on this object, it can't be ruled out, no matter how remote the possibility might be, that Oumuamua may instead be of artificial alien origin. That is not to say that it is, it probably isn't, but simply that it cannot be ruled out. But the story of Oumuamua grew even stranger in late June of 2018. In a paper by Marco, Micheli, and colleagues, they detail the discovery that Oumuamua accelerated as it left the inner solar system. Accelerated is perhaps too strong of a word here. It's more like Oumuamua left the solar system less slowly than it should have, given the gravitational effects on it from the sun. This would seemingly have a mundane answer, that Oumuamua was in fact a comet even though it didn't entirely look like one. Cometary outgassings can act as a kind of natural thruster and impart a bit more speed to an object than the effects of gravity alone can account for. The problem is no such outgassing was observed with Oumuamua. It could possibly be that we simply missed it when it happened, or that it was imperceptibly slow, or that the outgassing was difficult to detect with the data we have, such as outgassing from pure water ice, but that still should have blown off dust which should have been detectable. And there's another issue. Given Oumuamua's odd shape, any outgassing should have upset its tumbling, and that should have been detectable, though it's also possible that the outgassing came from a point on the object where it wouldn't have changed anything. But more recent research by Rafikov shows that it's likely that any kind of outgassing should have changed Oumuamua's rotational torque enough to destroy it. This mystery has since further deepened. In November of 2018, in a paper by David Trilling and colleagues, again linked below, they detail the results of an observation, or more precisely, a non-observation, of Oumuamua using the Spitzer Space Telescope. By non-observation, I mean that they looked for the object in infrared and didn't see it. That in itself is telling because they should have. It means that Oumuamua must be very small, on the order of hundreds of meters in size. This is odd indeed, because to have been seen at all in the earlier observations, it would require Oumuamua to be very highly reflective, unusually so. As Oumuamua revealed itself to be an increasingly strange object, the notion that it may be of alien origin has been increasingly looked at, remote though that possibility is. SETI teams, for example, just to be sure, listened to Oumuamua for radio emissions. None were detected, and while it's highly unlikely for this object to be of artificial origin, it's very likely a weird natural object, accumulated weirdness surrounding this object is raising some eyebrows. In a paper by Avi Loeb of Harvard, he details 6 of these strange attributes of this object. He points out that Oumuamua should have never been discovered in the first place. This is based on an earlier paper co-authored by Loeb, where it was predicted that the abundance of interstellar asteroids would be too small for it to be likely that we'd just happen to catch such an object serendipitously, as happened with Oumuamua, meaning that whatever spawned Oumuamua must be more common than what we see with our own solar system. Loeb also points out that Oumuamua originates from a very weird frame of reference, the LSR, or Local Standard of Rest. He goes on to point out that this is ideal if you want to camouflage an object if you want to hide its origins, though it's also possible that Oumuamua has just been wandering so long in the galaxy that it simply settled into this frame of reference. But there's more. Oumuamua would have had to leave its star system of origin with an unusually high velocity, meaning that whatever the circumstances of its ejection were, they are very likely rare and unusual. Also, there's the shape. Oumuamua would have to have a length at least 5 times its width, or possibly as much as 10. The most we've seen with solar system objects is 3, and then there is the Spitzer observation, which means the object must be small, and lastly, there was the unexplained acceleration. These attributes led Bialy and Loeb to author a paper that the acceleration could be due to solar radiation pressure if Oumuamua were very thin, a millimeter or less. This begins to look consistent, and I stress that, look consistent, with a light sail of artificial origin. But for it to be that, it would have to have been targeted towards our solar system. Standing for that possibility is the age of the Earth. Earth's oxygen has been visible to the galaxy for a very long period of time, well enough for astronomers from other star systems to have spotted Earth as an exoplanet and concluded that the unusual amounts of oxygen in our atmosphere was most likely the result of a biosphere. Perhaps at some other point, they might have found further evidence through the detection of other biosignatures of life on this world, and then sent a probe. Also marginally going for it would be the acceleration, which is still unexplained, but slow outgassing from a natural object seems far more likely there. Standing against it are several things. Firstly, what are the chances of just happening to spot an alien probe just as it passed through the solar system? Not very likely unless they pass through constantly. It seems more likely that rocks and ice coming in from interstellar space would be pretty common, especially if dying stars lose their Oort clouds into space, even if bearing odd attributes unfamiliar, so far as we know, to objects in our own solar system. Another issue is that Oumuamua appears to be tumbling, and that doesn't seem to be a good fit with a light sail. Also, Oumuamua seems to be traveling counterintuitively slow for an artificial object. It presumably took millions of years to get here, though who knows how an alien civilization might perceive time. Also, there's the apparent consistency in spectral studies of Oumuamua with objects in the outer solar system. It essentially looks like a reddish object that's been bombarded by radiation in the interstellar medium for long periods of time. On the other hand, it might have accumulated that dust over time. That's also a possibility to explain its high reflectivity. If Oumuamua were a piece of water ice that had a layer of material deposited on its surface, and that material was slowly stripped away during its encounter with the sun, that might not have been seen, and bright, fresh ice might explain the reflectivity. At the same time, it pays to weigh all options, both natural and artificial. I personally suspect that Oumuamua is a natural object that encountered unusual circumstances in past encounters with stars, or within its home star system, at least from what we know from our own solar system. But with new instrumentation coming online, more light might be shed on just how unusual of an object Oumuamua was. And while its close pass to Earth is weird, and it might be consistent with an alien light sail checking us out, it seems more likely that there are many such interstellar objects passing through the solar system on a constant basis, and if so, many should come to light when the Large Synoptic Survey Telescope comes online in 2019 with first science light in 2021. If, however, the LSST does not reveal many such objects, then Oumuamua will fast become the most interesting object we've ever seen, and intercepting it, which would be difficult but is possible, will become a priority very, very quickly. Thanks for listening. I am futurist and science fiction author John Michael Godier, and be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.